determine whether the lines L1 and L2 intersect, parallel or skew. So they intersect if there is a point P of coordinate x, y, z such that P is on L1 and P is on L2. That's the definition. So they intersect if there is such a point P. Here's L1 and here's L2. So in terms of the parameter, this means there is, say, parameter T for the line 1 and parameter S for line 2 such that the system equation of line 1 and line 2 both satisfy. So we need to use the different parameter here because so 2T, 2S, 6S, 4S, S. We choose two different parameters to solve the system equations because when T is run, then you have different points on the first line. When S run, you have different points on the second line. And we use two different parameters because this point run at the time T. So like T1, T2, T3, T4, T5, and so on. And if we use the same parameter, meaning they run at the same time, then we don't know whether at the exact time T, say, equal to 10, the point on line 1 is here, but maybe at the time 10, the point on line 2 is there. That's why we check with T on line 1 and S on line 2 such that at the time T equal to S, they meet here, or if such T and S exist. Okay, so here's strategy to check. We do it later for checking the intersection. So if there exists such T and S satisfy this system equation, then they intersect. What about parallel? They are parallel if, so let's say if light 1 has a vector direction, so if V1 is the direction vectors of the light 1, if V2 is a direction vector of light 2, they parallel if V1 is parallel to V2. So the direction vectors are parallel. So light 1 is here, light 2 is there. If the direction V1, so V1 is this line, so this direction, say V1, and V2, say V2 is this vector, direction vector. If they are parallel, then of course our light L1 and L2 are parallel. If the two directions are not parallel, then they are not parallel. Then the light L1 and L2 are not parallel. So to check whether V1 is parallel to V2, we check if there is a scalar, say K, the real number such that V1 equal to K times V2. So if there exists such a K, then the two vectors are parallel, and this implies the two lines are parallel. vector v1 and v2 can be computed, or we can obtain them by using the equation of L1 and L2. So v1 is obtained by using the coefficient of the parameter. So v1 in this case is 1, 4, 1, and v2 is 2, 6, 4. And yes, that's how we check they are parallel. And if they are not parallel and they don't intersect either, then they are skew. If L1 and L2 do not intersect, and L1 and L2 are not parallel, then L1 and L2 are skew. So actually they lie on different planes and they don't intersect. Okay, so let's check whether, for this example, it would be easier to check whether they parallel. This is because the direction vector can be seen directly from the equation here, and we can check the two vectors are parallel or not. So let's check whether they parallel first. We check if L1 and L2 are parallel. Okay, so the direction vectors of L1 is V1 equal to 1, 4, 1. So just the coefficient of the parameter here. And the direction vector of L2 is V2 equal to, so the coefficient 2, 6, 4. So we will check if V1 and V2 are parallel. So this means we check if they exist. We check whether there exists a parameter k, a real number k, such that V1 equal to k times V2. So V1 is 1, 4, 1. V2 is 2, 6, 4. This gives us 1 equal to 2k, 4, 6k, 1, 4k. So the first equation gives us k equal to 1 divided by 2. The second equation, 4 divided by 6. The third one, 1 divided by 4. So this is absolute, which is so this means that the two lines V1 is not parallel to V2, and hence L1 is not parallel to the line 2. So that's how we check whether they parallel or not. Now we check whether they intersect. L1 intersect L2. So as we said before, we only need to check whether there exists the parameters Ts such that the system of equations are satisfied. So this means we check if whether there is, we will check if whether there exists Ts such that this system equation holds. Okay, so x equal to 5 plus t equal to minus 2 plus 2s, y 17 40 equal to 7 minus 7 6s, and z 6 plus t minus 5 4s. So the first equation gives us t equal to minus 7 2s. So this the first one gives us t equal to minus 5 minus 2 minus 7 plus 2s, and we just plug in the second and the third. 17 4 times t minus 7 2s minus 7 6s, 6 plus t minus 7 plus 2s minus 5 4s. So here we have 17 28 8s minus 7 6s, 6 minus 7 so minus 1 plus 2s minus 5 4s. So here we have 20s 17 so minus 11, 8s 6s minus 7, and then minus 1 plus 5 4s 2s. So 2s minus 11 plus 11 minus 7, so 4, and the last one is 2s equal to 4. So these two equations, the two last equations, are the same, which give us s equal to 2, and we plug into the first equation, we can find t minus 7 plus 4 minus 3. Okay, so there exists such t and s. So ts equal to minus 3 2. This implies the two lines L1 and L2 intersect. And actually we can even find out what is the intersection point. And they intersect at the point. Now we plug in to find x, y, and z. Plug in the equation defining L1 or L2. So here let's just pick the one defined L1. So minus 5 plus minus 3, so t equal to -3. 2, 17 -3, so 17 -12, which is 5. 6 -3, 3. So the intersection point is 2, 5, 3. This is the coordinate of the intersection point. And since they intersect, they cannot be skewed.